Stay awake later at night so that
I can take a nap in the middle of school.
yes, you can. Just be sneaky about it.
All right, here we go. All right, you guys, we are at the point, we're getting close to the test. The test is actually 1 week from today. Tuesday next week, we go. Now, we still have one lesson to learn. It's this lesson 4-5. This will take us a solid 2 days. It could even take us longer. It could take us longer. It could take us 2.5 days. I don't know. We'll get there eventually, okay? All right. Now, here's what you're doing. You're going to take a quadratic equation, okay? A quadratic equation, and I didn't write this, so you might want to write this down, and you're going to solve by what? Factoring. Okay. So your factoring skills that you learned in the last 4 days in here, they come into play right now. So if you're good at this, good at factoring, this probably won't be too hard for you. Okay? All right. Okay. Before I start factoring, solving, I got to talk about this little term here. It's called a zero. What's a zero in Algebra 2 or any mathematics course?
Like where it starts?
It's a zero. Okay, but
It's
watch
no
this.
value.
Okay, it's right here. Wherever the graph of the function y equals f of x intersects what?
Y-axis.
The what?
Y-axis.
Doesn't say y-axis, it says
X-axis.
x-axis. So wherever your graph crosses the x-axis turns out to be your what?
0.
Your zero. And it says right here, f of x equals 0. But what's f of x?
Y.
Y. So what happens is, when I say, where's your 0, you're supposed to be thinking, wherever the y value is 0. Where's the y value always going to be 0?
X-axis.
Wherever it intersects the x-axis. That's where y will always be 0. So guys, if I look right now at these three graphs, ready? You're supposed to look at this graph, which is a line, and tell me the 0. Well, yeah, it's always going to be, and the answer is always x. It's right there wherever it crosses the x-axis, so it's really going to happen at what? 2. When x is 2, what do you get out for y? 0. So I'm thinking this isn't so bad. If you're looking for zeros, you're just looking for where the graph crosses the x-axis. If I let x be 2, what do I get? 0. That's it. What about the next one?
Y -2.
Yeah, -2. Okay, that wasn't too hard. Now lines are if lines are diagonal, they will cross the x-axis somewhere. You just have to go find it. Now, if you run into a parabola, which is what we're really doing today, we're really not doing lines. This is what we're doing. If you run into a parabola, parabolas can touch the x-axis what? Twice. So what's the 0 in this one? 1 and -1. And here I just said x equals plus or minus 1. Okay? Is that okay with you guys? So this point right here is, if I let x be 1, I get out 0. Here this point is, if I let x be -1, I get out 0. So the zeros are whatever x value gives you 0. Okay? And if you look up here, guys, if you read the rest of this, it says the value of x at any of these intersection points is called the 0. So when you say what's the 0, you have to tell me the value of x. And that's what we did down there. A quick definition, a value of x for which f of x is equal to 0 is a 0 of the function. Well, this makes more sense, I think. If you call this your 0, x equals 2, then what you're saying is, if you stick 2 into your function, f of 2, you better get out what? You better get out 0. And here's the function back here. Just here's the function. So what they did is they stuck the 2 into the function. 3 times 2 minus 6. They got 0. So that's how you can check your zeros. I want to know if my zero is right. I'll just check it. Put it into your function, see if you get 0. So I'm going to ask you to check once today, just once. So when I say check it, just put it into your function, see if you get 0. Do you get a feeling of what a 0 is?
Mm-hmm.
It's where the graph
Intersects.
intersects
X-axis.
the x-axis. It's actually the x value that if you plug it into your function, you're going to get out what?
Why?
0. You'll get out 0. Okay. I am not going to talk about this. If you want to read it later, it does make sense. I just don't want to talk about it. Here's what I want to talk about. Right here. Okay, that's me. This is called the zero product property. Zero product property. So what is the zero product property? It's going to say something like this. Okay, if you take two numbers and you multiply them, A times B. What do you know for sure about A or B? What about A?
Equals 0.
A has to be 0 for this to work, right? Is 0 times any number 0? Yeah. But what if A isn't 0? Then B has to be 0, right? So more or less, this is the property you're working with today. Either A will be 0 or B will be 0. One of them's got to be 0 or else it doesn't work. Correct? If A was 5 and B was 10, would you get 0? No. It doesn't work. One of them's got to be 0. So if you know that much about this property, then you should be able to answer this question. Okay, what if I factor a trinomial? And I factor it into x minus 8 times x plus 2. And I ask you, when will this number times this number equal 0, just like I asked you up here? You didn't have any problems. You said either A is 0 or B is 0, and then you said, that's it. I said, sure. So when is x minus 8 times x plus 2 0? What's the answer now? I'm looking for an answer, a solution to this equation. Nobody's talking. Okay, I'll throw a number at you. Ready? Let's throw 10 at you.
Okay.
Okay, let's put a 10 in. Let's put a 10 in. What's 10 minus 8? 2 times 10 plus 2. Is 2 times 12 0?
No.
That's not the answer. I was kidding around. Okay, I'm looking for the answer. 0, I heard 0. Let's try it. 0 goes in, 0 goes in. Somebody said, that's the solution. What's 0 minus 8? What's 0 plus 2? Is this times this 0?
No.
Ah, didn't work.
I see.
Okay, come on guys, you're getting there.
I understand.
Okay, go, raise your hand. John,
X can either equal 8 or -2.
he says 8 or -2. He said or, sorry. Is he right?
Yeah.
Let's put his 8 in, ready? 8 goes in, 8 goes in, what do you get? 0 times 10, is he right? Yep, he got that one. Or he says this one. Is -2 right? -2 there, -2 there. That'd be 0 times what? Oh, he's right again. So here's what it is. He did that probably in his head. I probably won't do that on paper. I'll do this. We know that for this to be 0, we would have to have it equal to 0. We know this has to be 0 sometime, so we set it equal to 0. So we're going to solve it, and when we solve it, we add 8, and we get John's answer. We subtract 2, and we get John's answer. So this is the work on how to get it. That's it. Set your factors equal to 0, and you've got it. Now, I got to tell you something about this form. You're looking at an equation in what form? Factored form. Every time you do a problem today, will you put it in what form? Factored form, which means you have to do what? Factor it. That's why you learned to factor. Okay? Can we start? Okay, let's go. All right, next up, go back, and down. All right, so I want you about here. Somewhere right there, okay?
Are you recording?
Oh yeah, I got it going. You guys were too slow today. You were supposed to remind me a long time ago.
Well,
Okay, ready? Come up. Let's take that problem. What are the what? Solutions. Okay, what are the solutions of the quadratic equation x squared minus 7x equals 12, negative 12? I'm going to rewrite this. Okay, now your job is this. Put your equation in what form?
factor.
No, that's the eventual goal, but the first goal is put it in what form? Standard. Now standard means ax squared plus bx plus c. Get everything on one side. So you say x squared minus 7x what?
Plus 12.
Plus 12 equals what?
0.
0. So guys, you're looking for the zeros, which are the solutions to your equation. Well, out of standard form, let's go to what form? Factor. So can you guys take about 10 seconds and factor? There was no GCF, so I just started factoring x times x. It's a positive 12. So it's got to be positive times positive or negative times negative.
Negative.
Has to be negative negative because of the negative 7, right?
Mhm.
Go over here, just kind of jot your numbers down. What do you think?
Negative 3 times negative 4.
Okay, 3 and 4. Gotcha. Okay. Standard form, set it equal to 0. Factored form, you factor it. Now, what are the, here it comes, last thing. What are the what? What are the solutions? Well, do you guys realize I'm asking you this? When will A times B equal 0? When either this is 0 or whenever this is 0, right? And I know you guys can probably do this in your head. What's the answer here? 3.
4.
Done. That's the answer. But hang on. If I were to show work, I would say, when is x minus 3 0? When x equals 3? When is this one going to be 0? When x equals what? 4.
You have to do that.
No, you don't. But I'm telling you, you're going to get stuck, and you better know this. When you're stuck, set them equal to 0 and solve them. Can you do me a favor? This is the only one I want you to check. How do you check to see if these are correct? Plug it into your original, and you know what? You can go here, or you could just go right here. It doesn't matter. So let's do a quick check. Pick a number to check.
4.
4? Okay, let's do 4. So if you did 4, I'm going to go here, guys. I'm going to check this right here. That would be 4 squared
47 times 4.
minus 7 times 4 plus 12, right? Equals 0. 4 times 4.
16.
Take away,
28.
add 12. What do you think about the 16 and the plus 12 in the back? Isn't that 28, these
Yeah.
two? 28, take away 28.
0.
Check. If you let x be 4, you're going to get 0. That's what we're looking for. When is my equation equal to 0? You okay? We don't have to check the 3, do we?
No.
Okay. You can. Just pop it in your calculator. Okay, guys, we got to keep moving. Let's do the next one. Let's factor. Put it, sorry, I should have said, let's put it in standard form, then factor it, and then solve it. Move it over. What's it gonna be? Minus 30x. You are now in what we call standard form. AX, where plus BX plus C equals 0. Okay, next. Put it in what form?
Factory.
Factored form, which means you have to do all the work.
GC.
What'd you, do you see a GCF?
Mm-hmm.
What is it?
5x.
5x. Okay, took out a 5x, right? Got what?
X
X
minus
X
minus 6.
minus
Yeah,
6. You good?
Yeah.
You know, if you raise your hand when you're not good, it's okay. Just say something. Okay, so here's your A, guys. Here's your A times your B. And you know for two numbers to multiply to give you 0, one's got to be 0. So when is the first one 0? No, the first one's, this one's the first one. When is 5x equal to 0? Here's the second one. Yeah, divide by 5, right? There it is. 0 is a 0. Where's your 0? Add 0. When x is 0, you're going to get 0. Okay. What about the other one? 6.
Oh, I'm
Good.
good.
Now, guys, could we check 0 and could we check 6? Yeah. And you guys, you can put 0 in so quick up there, you could check that in about, honestly, 3 seconds. The 6 would take you a little longer. Okay? I'm not going to do it. Okay? Move on. Go here. Does anybody have this one? I'll check yours right now. You have it?
Oh, well, I got the factory.
No, no, I want the answers.
You want everything.
I want the answers. Put it in standard form, which means get 0 on one side. Factor it, and then solve. Like that. Solve. First step was right there. Get it in standard form. Get 0 on one side. Was there a GCF? No. Is this a perfect trinomial? No. Oh no. Is this the difficult one?
Yes.
Yes. Okay. So this is the difficult one. Here we go. Okay. How do you get 3x squared? 3x times x. How do you get this? A negative. Positive times a negative. We're almost there, guys. We just need numbers. 40 is not fun. It is not fun because you have to do what? 1 and 40, 40 and 1. Right? 220, 22. 10, 4, 4, 10. 5, 8, 8, 5. Look at the options you have. Lots. I recommend start where? 5, 8, 8, 5. I am not going to tell you that's the answer, but it is. It typically is. Okay, tell me, which one? 5, 8, let's do 5, 8. Here we go. 5, 8. Inner's what? 5x. Outer's what? Negative 24x. Together that makes negative 19x. Woohoo! We got it. We're good. Okay. Now, so am I done? Guys, am I done? No. Now, listen. This is what you did. You went standard form, factored form, and now you need what? Solutions. You need the solutions. So when will A times B equal 0? This one's easy, right? X minus 8 equals 0. The answer is what? 8. Right? That was the easy one. 3x plus 5.
Oh.
When's it 0? 2 and 2/3. Never mind. Is it negative?
It's negative, I got negative 5/3.
5, which is negative 1 and 2. Okay. Let's just try it. Here we go. When is this going to be 0? This is what I told you. If you want to know, set it equal to 0, solve it, subtract your 5, divide by what? Divide by 3, right? The answer is?
Like 5 or
The other answer is negative 5. You got negative 7.
I had 8. I put 8 twice.
Oh. Oh, okay, gotcha. You put an 8 right here?
Yeah.
Oh, okay. Questions? Okay. The group looks like they got it, or the group looks tired, I can't tell. Alright, here we go. Start up. Let's try and get this one done. I don't think the swimming pool one we will get to, but will you do me a favor when you go to your assignment tonight? The last problem is like the swimming pool problem in your assignment. You don't have to do it unless we get the swimming pool problem done, which I don't know if we
I
will.
like we'll have time.
Okay. Ready? Here we go. An object, let's just say a baseball, is dropped from a height of 1,500 feet above the ground. The function h equals negative 16t squared plus 1,500 gives the object's what? Height in feet during the free fall at t seconds. So we're comparing seconds to the what? Height of the ball. So at 0 seconds, how high is the ball?
0.
Is it on the ground?
No, it's 1,500 feet up in the air.
An object is dropped from 1,500 feet above ground. Here's the deal. You guys, you can look at the equation. You can know where the ball is right away. Remember this? You could sketch, quick, you could sketch. You can sketch the parabola. First of all, it is a parabola, right? Because it's t squared. The a value is negative, so the parabola goes which way? This way? Down. Okay. Do you guys remember also that there's an easy way for you to get the y-intercept? Where's the y-intercept?
C.
It is C. That is your y-intercept. Look up here. Which one is C?
0. Oh, yeah, 1,300.
It's 1,500. You guys, this is your y-intercept. The ball, the baseball starts where?
1,500 feet.
Right there. Okay, then as time starts, you drop the ball. 0 seconds. 1, 2, 3, 4, 5 seconds. The ball goes where? Down. It actually, the parabola keeps going, but the actual, it's going to stop there. So really, this graph is only good from where to where? Where I drop it until it hits what? The ground. This is all we're going to concentrate on is this. But this is part of a parabola, right? Okay, here we go. First question, when will the object, the baseball, be what?
1,100 feet.
Okay, 1,100 feet. Well, that's right about here. So right about there. So this is the answer down here, isn't it? That's the answer?
Sure.
Okay, well, how am I going to do this? It's an equation. H 1100, thank you. I'm going to replace the height of the ball with where I want it to be. I want it to be at 1100 equals this, right? Plus 1,500, right? Now what? Put it in standard form, which means get 0 over here, guys. Okay, how do I get 1,100 off that side? Minus 1,100, which would get you
400.
400. Okay? Factor. GCF. What's the GCF? Anybody know it? 4. I heard 4. 4 is good. It's not the best. 8. I'm not sure if 8 goes into. Yeah, 8 goes into there. 16. I'd take out 16. Okay. And I would also take out, like Taylor says, negative 16. If you divide by negative 16, you get t squared minus, because it's 400 divided by negative 25, isn't it? You're looking for your best friend?
Yeah.
Look inside the parentheses. Difference of 2 perfect squares. This times this. What's it going to be? T plus 5, t minus 5, right? Okay. You have how many multipliers? How many factors? No. You have 3. A times B times C. You actually have 3 multipliers, 3 factors. So when will these 3 factors be equal to 0? What? They have to be 0 to get 0.
Plus or negative 5.
Okay, so this one's negative 5, this one's positive 5, right? So when the time equals what? Plus or minus 5 seconds. What about this one right here?
Wouldn't it be like 5 over negative 5/16?
Hang on now. When will this number equal 0?
16.
No, that'd be negative
0.
Yeah, Isaac?
When it equals, when a equals 0, x equals 0, because it'll go through.
Guys, didn't I tell you when you want to know when will that factor be 0, set it equal what?
0.
Set it equal 0. When will negative 16 equal 0? Never. If it doesn't have a variable, it will never be 0. This is called a constant multiplier. It never changes. Without a variable, it won't change. See this one? This number can change anytime you want it to, just like t be something. But our answer is 5 and negative 5. Because there's no answer here. Now there's one answer up here that doesn't make any sense.
What can't be negative?
It can't be negative 5 because you don't count backwards. So what happens is at 0 seconds, you're at 1500. 1, 2, 3, 4, 5. There it is. When will the baseball be 1100 feet in the air?
5 seconds.
At 5 seconds. You okay?
Mm-hmm.
Okay. Now, can we do it again? Your next one says, when will the ball, baseball, be what?
Hit the ground.
Oh, yours says hit the ground. Okay. Yours doesn't say what mine says, so let's change that. Hit the ground. Okay. Hit the ground. Well, what do you guys know about the height of the ball when it hits the ground?
1100.
Well,
The height will be 0.
0, isn't it? Isn't the height going to be 0? So you should put a 0 in this time. Right? Okay. Factor. It's already in standard form. Factor. You see a GCF?
Oh.
16 does not go into 15. Don't try 16. What? 8 doesn't work. 16 doesn't work. 4 works. I would have taken out not just 4. I would have taken out negative, which would give me 4t squared, right? Plus, sorry, minus
Oh, yeah.
375. Thank you. Okay. All right. This is where this problem takes a little twist on you. Ready? Here's the deal. You have it factored. When will this number times this number give you 0? We'll set them equal to 0 and solve it. Oh, you know what I forgot to say to you? Can you factor this anymore? Is this the difference of 2 perfect squares? Perfect? Yes. Perfect? No. Okay. Well, so here's the deal. Now you gotta go back to 9th grade, because I haven't told you this yet. You gotta go back to 9th grade. When will this be 0?
T 0.
You need to solve it. This is what I keep telling you. If you want to know when it's 0, solve it. Okay, so how do you solve that equation? Solve for t.
Add 375.
Add 375, right? So you get 375 over there. Now solve for t. Divide by 4. You're going to get 93.75. Okay, come over here.
Square root.
This is where your 9th grade teacher comes in handy right now.
Square root.
Square root.
Okay, yeah, how do you solve for t when t is squared?
Square root.
Square root. Okay, go for it. How many seconds before it hits the ground? 9 something, right? 967. Can we just say this? Can we just round it 7? 9.7?
Sure.
And remember, guys, there are 2 answers, 2 quadratics. We haven't talked about it, but there are. Positive 9.7 times positive 9.7 and negative 9.7
Do
times
we have
negative
to
9.7.
put the negative because there wouldn't be.
Which one doesn't even make sense?
Negative.
Throw it out. Throw out your what?
Negative.
Okay, so the answer is
9.7 seconds.
9.7 seconds the baseball hits the ground. What's a reasonable domain? By the way, which one was domain? The x is, but can you say the,
X value.
but it's not x. Look at your equation.
Something.
Isn't it time t?
Yeah.
So what's a reasonable domain? Time will range between, look, 0 to what?
0 to
9.7. You guys should say time goes from here, 0 seconds to what? 9.7. Because after 9.7, your answer is always going to be 0. It sits on the ground forever. How about this one? Range would be your height.
Would be 1500.
Range is between, the height of the ball ranges between what and what?
0 and 1500.
Greater than 0. Less than 1500. Right? That little sketch I made, that helps me when I do a problem because I can go back and look at the ball and I can go, oh, there's the domain, the x's, and here's the range, the y's, 0 to 1500, 0 to 9.7. It helps me. I don't know. Does it help you? I'm not making you do this, but this is kind of nice to see the parabola, right? Right, Ethan? Even with your eyes closed, you can probably see the parabola. Okay. Are you okay? We did pretty good, guys. There is not one class that got that far, and we still have about 3 minutes left. 2 minutes. Okay. Good? Yeah. All right. You guys remember yesterday's quiz? Yeah. We got 6 out of 6. You can keep it. Did I say this?
Yeah.
Keep it for a bonus, right?
Yeah.
Okay, let's do that. Let's just get those out. I don't want to.
I got one more on it. I know I got one.
Keep it though, we can put it in.
11 out of 20 got a perfect paper. Just so you know.
Oh, that's just it was 7
What are you talking about? You don't have it.
No neighbor. You got a no neighbor? Oh, no, here.
I got 0.
Colton's right here.
I took it off twice.
John.
Other hand.
And 11 and a half. Give me my phone stuff, please.
Oh, yeah.
Gavin. Adrian. Next time. Elizabeth, Travis, Sam, Ethan, Faith, and Tyler, John, Anna. Anna? We still you can, yeah. Okay, did you go? Did you get it or not?
Got it.
Okay. Have a good day.
Actually felt pretty good about that, man.
Well, I'm glad you feel good about that. I'm gonna jump on.